All right. Today, what we want to look at is some questions from matrices. All right. So here goes. Here goes question number one. It says, calculate the value of x and y in the matrix equation below. So we want to calculate the values of x and y in the matrix equation below. Right here, what we have to do, we have to multiply this matrix here by that matrix there, all right? And then after that, we're gonna use equated matrices to solve the values there, right? So definitely, when we multiply matrix, we're multiplying rows by columns. So I'm gonna highlight the rows here. Here is the row, that's the other row. So we're gonna be multiplying rows by columns. So I'm gonna put the columns in green. Here is a column, and this is the other column. Technically speaking, we're talking about this is row 1, row 2. This is column 1, column 2. So in multiplying rows by columns, we're going to attempt the ideas like this. It's going to be the first row will multiply by all the columns, and then the second row will multiply by all the columns. So let's go through. So first element in row 1 times the first element in column 1, -4. And we're adding that to 5 times 2. So first element in row 1 with first element in column 1. Second element in row 1, second element in column 1. And that's a row by column. It's like across and down, across with down. So we went across and down. Okay, so that's the idea, all right? All right, so row 1 will still go with the other column. So row 1, we have 1 times 1, and we're adding that to 5 times 9. All right, row 1 was used to do the 2 columns. So now row 2 is gonna do the 2 columns. So it's 2 times -4 plus y times 2. And then 2 times 1 plus y times 9. So this matrix here is equal to x, 46, 6, 65. It is equal to that. Let's simplify this. What we have on this side is -4 plus 10. This is 1 plus 45. This is -8 plus 2y, and this is 2 plus 9y in this matrix, and this is equal to x, 46, 6, 65. Definitely, you could see, though, let me go one step further. If I go one step further, we're talking about this is going to give me a 6. This is going to give me a 46 in terms of a number. So let's write 6, 46. We could spin this anyhow we want it. We could say 2y minus 8 or -8 plus 2y, that's fine. 9y plus 2 or 2 plus 9y, that's fine. So this is equal to x, 46, 6, 65. Now, corresponding spots are equal. For example, 6 is equal to x. You could see that 46 is 46. And then 2y minus 8 is going to equal to 6. And 9y plus 2 is equal to 65. And we're going to use that to find the values for x and y. So luckily, the x value is already worked out where we saw for ourselves that they are in the corresponding spots already. So you could see that the x and the 6, so we could say x is equal to 6, and that's done. In order to find a value for y, I have 2 options. So I'm going to pick on 1. I could always link the 2y to the 6. Let's go with that. So finding y, in finding y, we could say 2y minus 8 is equal to 6. Let's add 8 to both sides. 2y is equal to 14. Then I divide both sides by 2. Y is equal to 7. So there it is. I have a value for y. But I never had to do it that way. I could have used this situation. 9y plus 2 equal to 65. Let's see. 9y plus 2 equal to 65. I will be subtracting 2 from both sides. 9y is equal to 63. If I divide both sides by 9, then y is equal to 7. 7 nines is 63. So as you could see, this is a solution 1, and here is a solution 2. You don't need to do both, but I'm just showing that, hey, we have many ways of getting through to our answers. Definitely, we want to conclude here. You could see that x is 6 and y is 7, right? X is 6 and y is 7. There we go. X 6 and y is 7. All right. So that's the solution for that. All right. There is another question here that we're looking at same time. So we're multiplying here. We're multiplying here. All right. Remember the multiplication principle, row by column. So that's my row. That's another row. And then I'm going to pick up my columns. Here is my column, one of my columns, another column, another column. So we're multiplying row by columns, or we could say across and down, depending on how you feel. So this is row 1, this is row 2, and then we have column 1, column 2, column 3. So let's see, right, what's going on. One of the ways in which I use to test what's going on, I write down this is a 2 by 2 matrix, and this is a 2 by 3 matrix. The inner numbers will tell me if the inner numbers are the same, it means that they can be multiplied. That means it's compatible. And then the outer ones, which is a 2 by 3, will tell me the shape of the new matrix. So this is the shape of the new matrix, all right? Right. All right, so we're gonna embark on that idea right about now. Let's go. All right, remember row by column, so that's what we're doing. So row 1, 5, 4. So let's put it over here. So it's gonna be 5 times 2 plus 4 times 0. All right, then so that's row 1, column 1. Still in row 1, 5 times 1, I'm now in column 2, plus 4 times 3. So row 1 has just exhausted column 2. Row 1 will exhaust column 3. 5 times -4 plus 4 times 6. Now we have just exhausted using row 1. So row 1 was used on column 1, column 2, and column 3. Now we're going to go with row 2 in a similar fashion. So -3 times 2 plus -2 times 0. Then we have -3 times 1 plus -2 times 3. Still with row 2, -3 times -4 plus -2 times 6. Now, putting it together, 10 plus 0, 5 plus 12, -20 plus 24, -6 plus 0, -3 minus 6, -12 minus 12. So let's look through for errors, because it's easy that you make errors here, very, very easily. You can, response is a 10 right there. It is a 17 right there. -20 and a +24, that's a +4. -6 right there, and -9 right there, and a -24 right there. As you see, our final matrix was in the form of a 2 by 3. That's the order of that matrix. All right, so there it is. The question that follows says state why two matrices in A and I, which is above, are conformable by multiplication. All right, we had a 2 by 2 matrix and we had a 2 by 3 matrix. For in order, and then this refers to rows. So that's rows, and this is column, this is row, and this is column. So what we wanna look at though is the fact that in the first matrix, when the number of columns in the first matrix is equal to the number of rows from the second matrix, they are compatible to multiply. So normally I would just tell my kids that, hey, if you set up the order of the matrices, and then you do this, the inner numbers, if the inner numbers are the same, then yes, you can multiply. And then we don't even want to even talk about the new shape because they didn't ask, but the new shape will be the outer shells. But in context of the question, as long as the inner numbers are okay, which means if the number of columns from the first matrix is equal to the number of rows from the second matrix, then yes, they are conformable for multiplication. Hence, we were able to complete that one up front. Determine the inverse of 5, 4, -3, -2. There's a formula for inverse. The formula for inverse says that you want to have 1 over the determinant of the matrix, and you multiply that by the adjoint of the matrix. Remember though, the determinant of the matrix is the product of the main diagonal minus the product of the other diagonal. So and then the adjoint of a matrix is to switch the elements on the main. So for example, the adjoint, let me work out these just for us. Let's work out the determinant now. The determinant is equal to 5 times -2 subtract -3 times 4. So this will give us -10. And then this is a plus 12. So -10. And then we'll end up with a plus 12 for this part, which means that we definitely got 2 for that. Now, the adjoint, let's work out the adjoint. The adjoint of the matrix is going to equal to, we're going to switch these elements, switch them, meaning they're going to exchange places. So you could see the -2 and the 5 switch right here. -2 and 5, they do switch. And then we're going to change the signs on the others. So what becomes positive was a negative, and negative becomes a positive. So now the inverse overall is just to set up this idea where we put 1 over the determinant, and we're going to multiply that idea by the adjoint of the matrix. This gives us a half times -2, a half times -4, a half times 3, a half times 5. Technically, when we had this in itself, this is the inverse. But I'm just simplifying the idea some more. But this is the inverse already. In simplification, I know some persons would have done this. So you could see that, you could see for yourself right now that the 2 cancel itself. So that's a -1 in that spot. 2 into itself, 2 into 4, 2 times, so that's a -2 in that spot. So we have 3 over 2 here, and we have 5 over 2 here. And this is the inverse of that matrix that we had. There you go. That's our inverse right there. All right. All right, guys. Thank you very much for watching. Please like, leave a comment, and subscribe to Daddy Maths Concepts. See you next time. Bye-bye.